Hey guys, so today we're going to be drawing the molecule beryllium pentafluoride. It is a negatively charged molecule, so it is an ion. We're going to go ahead and start by counting our valence electrons, and this molecule is going to have 42 valence electrons. Now our beryllium atom is going to be in the center, and we're going to bond 5 fluoride atoms to our central beryllium. After we add our remaining electrons, we are going to notice that beryllium is going to have a lone pair in this case. This is going to give us a hybridization of sp3d2 because of our 6 orbitals, as well as a molecular shape of square pyramidal. Now it is a negatively charged molecule, so we must signify that with brackets. Now that we know our hybridization and our molecular geometry for our atom, we're going to go ahead and draw the VSEPR diagram. So I went ahead and added a box just to better illustrate the shape, but we're going to go ahead and add the beryllium atom in the center as well as the fluoride atoms on each of the corner and directly on top of the box. I'm going to show the bonds for each fluoride atom with some legs that are either striped or wedged. Now these legs are just to illustrate that these 4 fluorides are going to be on the same plane. Now I'm going to add a line to connect our top fluoride with our beryllium atom. I'm going to add in our remaining electrons, as well as, of course, our lone pair on our beryllium atom. Now I'm going to add some lines from that top fluoride atom to the rest of them just to better illustrate our shape of our molecule. Now with these lines we can better see the faces of our square pyramidal shape. Since this molecule is negatively charged, we are going to add the brackets to see that. And finally we're going to add our bond angle, and that's going to be less than 90 degrees. And this is our VSEPR diagram. Now here we can see the atomic orbital of our molecule. The 4 fluoride atoms that are on each corner of the box are in the equatorial plane, as well as the fluoride atom at the top, giving us our square pyramidal shape. And here we can see our atomic orbital overlap, where each of our hybridized sp3d2 orbitals of our central atom bond with the 2p orbitals of each of our fluoride atoms. And of course our lone pair below the central beryllium. And here we can see our molecule made with some building blocks, where we see the 4 fluoride atoms on that equatorial plane, that top fluoride atom giving us our square pyramidal shape, as well as that lone pair on the bottom. Alright, so here we're going to show you the box diagram for this molecule. Now in beryllium, the central atom, the ground state, normally has 6 valence electrons. However, since it is a negatively charged ion, we are going to add that last electron right here. Now, with a little bit of energy, we are going to promote 2 of these electrons, and those are going to go into the 5d orbital. Now, after we promote these 2 electrons to the 5d orbital, the rest of the p orbitals are going to come over, and the lone pair in the 5s orbital is coming over as well. As we can see, we have 5 valence electrons that are ready to pair with the 5 fluoride ions. Now we're going to go ahead and hybridize all of these electrons, and those are all going to go into our sp3d2 orbital. And I'm just going to fill that in for you guys. Now we're going to transfer over our lone pairs as well as our 5 electrons that are ready to be bonded with each fluoride atom. Now, each fluoride atom has 7 valence electrons, and that last electron is going to bond with each of the lone electrons in the sp3d2 orbital. Now, since there are 5, we are going to have 5 sigma bonds, and I'm just going to fill those in for each fluoride atom that we do have, giving us a total of 5 sigma bonds and 1 lone pair. And that's going to be our bonded state for beryllium. And now we're ready to draw our contour diagram. So we're going to start off almost similar to our Vesper diagram. We're going to put a fluoride atom in each of the corners of the box. And I'm going to go ahead and draw two lines that bisect the box for each corner, opposite corner, and one line to connect the top fluoride atom to the beryllium. Now we're going to go ahead and put our central beryllium atom in the center, and I'm going to go ahead and draw all the orbitals, all the sp3d2 orbitals for beryllium. Now in each of these orbitals we're going to have 2 electrons at the end of the orbital. And these are going to be the ones, barring the lone pair, that bond with the fluoride atoms. And I'm going to go ahead and draw the fluoride orbitals that bond with these electrons right now. Now notice that each fluoride has a 2p orbital, and this orbital is going to be the one that bonds with our sp3d2 orbital for our central atom beryllium. We're going to go ahead and mark all those 2p orbitals for the fluoride atoms, and we're going to go ahead and mark every bond in this molecule. And that's going to be with a sigma bond. And finally, we're just going to go ahead and mark that our lone pair is right here, and put in the bond angles. That is going to be less than 90 degrees. Because again, the lone pair repulsion is greater than bonding pair repulsion. Finally, we're going to add some lines like we did in the Vesper diagram to better show the faces of this molecule. And lastly, we're going to add our brackets to signify that this is in fact an ion. And there you have it. That's how you draw the Vesper, the box diagram, and the contour diagram for our molecule, TeF5-.